is our second lesson in exponents, and it's going to be a final one. Okay, and we will hopefully move on after that to other things. That makes sense. But anyway, right. So I'll start by drawing two kind of exponents that we saw the last lesson. So we saw y equal 3 to the power x, which is like a plane taking off. Okay, it's blowing up to infinity. Okay, if I go x equal minus infinity, if I put minus infinity, okay, 3 to the power of minus infinity, what is that? Okay, it's the same as 1 divided by 3 to the power of infinity. Okay, I didn't really mention it in the last lesson, but you do know that, remember that from the rules of exponents. If you have a negative exponent, it's the same as it's 1 divided by the positive exponent. And you know that 1 divided by 3 power infinity is 1 divided by infinity, which is 0. Okay? So we did mention in the last lesson that we have a horizontal asymptote. Okay? That graph gets closer and closer to it when x approaches in minus infinity, okay, but never crosses it. On the other hand, if I have, instead of a 3, I have a quarter, number less than 1, power infinity, it will approach 0, the asymptote y equals 0 when x is infinity. When that is infinity, a quarter power infinity, a quarter time, a quarter time, a quarter. Infinite number of times will get closer and closer to 0. Okay? Both of these graphs cross the y-axis. The y-intercept is, what is the y-intercept here? Because it takes them a little while. They didn't have coffee, just forgive them. Bless them, it took them a while, but they got it eventually. Josie got it eventually, okay? So it crosses here in 0, 1. Because anything power 0 is 1. Okay? Now we're adding something to it. So I want to add, I'll do a different color. Let's say y equal half times 3 to the power of x. Okay? So I'm multiplying it by some kind of, we'll call it an a constant. Okay? And this one I'll do another graph, y equal 2 times a quarter to the power of x. And my question is, what's going to happen? Okay, without actually substituting different x and doing, what would that multiplying will do to these graphs? I'll just pause here because the guys I think will take a little while here. They're a little bit sleepy. Alright, so the guys over here realize that by having that 2 time, it's going to make each y value double. Okay? So this, whatever it was, will go to there. This will go to there. This will go to there. This will go to there. 1 is going to go to 2. And so on and so on and so on. So we're going to have a line that is higher up. It's not a vertical shift because you're not moving the graph in equal amount. It's not just moving it up. It is, like Ali said, also going to be steeper in each point. Okay? And in the same way, if we're just halving all the values, so that's 1 will become half. This will be a bit smaller, smaller, smaller. So we're going to have a graph that is less steep and closer to the x-axis in each point. Okay? Now, let's do one more in the green. Okay? Let's have a look at y equal minus half times 3 to the power of x. Okay? What is that going to look like? What is that going to look like if I do y equal minus 2? I'll write it down here. Y equal minus 2 times a quarter power x. Okay? What's going to happen now? Okay, so we need to remember, whenever I put a minus, because effectively what I've done, I just put a minus. By putting a minus here, what I'm doing, I'm flipping the graph. I'm looking at the red right now. Okay? More mathematically speaking, I'm reflecting the red line around the x-axis. So now it's going to be like that. Okay? So that is y equal minus half times 3 to the power of x. It's getting flipped around. The same thing here, okay? I take the red graph, from 2 I put minus 2, so I'm going to reflect it around the x-axis. Wherever I have, let's say, positive 2, now it's going to be negative 2. Positive 3, negative 3. Okay? So now, I'll just summarize. I'll just pause here and summarize. Alright guys, to summarize, I'll add something and then also we summarize. So, the general formula for exponent function is a times b to the power x plus q. Okay? The b, we already mentioned, is always a positive number. So always, if you remember, when I did the power of the x, it was always positive. Okay? And we've got two kinds of graphs going on here. If b is larger than 1, it's taking off. If b is smaller than 1, like a quarter or half, it's landing. Okay? So far, it's pretty just basic stuff. Now we're looking at what a can do. Okay, so I can multiply, just like as I showed you now, I can multiply that b power x by a. If a is larger than 1, I use the word stretch. It's going to start lifting it up, but it's not a vertical shift, it's just a stretch. Okay, so I'll draw 1. So let's say we're looking at this graph. Okay, that's taking off. If I have a equal 2, let's say, okay, let's say a equal 2, I multiply it by 2, it's going to stretch it up. Okay. If I use an a between 0 and 1, it's going to compress everything. So let's say I'm taking the same graph, okay, with a b with it's taking off, and I'm putting a equal half, then it's going to compress it down. Okay. Now I can use a, which is actually negative. Okay. Negative a will flip the graph. It will reflect it over the x-axis. So this landing graph, okay, b smaller than 1, if I give it the negative a, let's say minus 2, okay, then it's just going to flip it down, or minus 1 in this case. It's going to flip it down. Okay. If I take this graph, okay, b larger than 1, and I give it the a, which is a negative 1, we'll flip it down. The only thing we didn't discuss, but it's going to be dead easy for you, is that q. What does that q mean? If I'm adding, let's say, 2 plus 2, what is that going to do? Vertical shift. Okay, so whenever we plus or minus, is a vertical shift. We plus, we're moving it up. We're minusing, it's going down. So let's just take, let's say, this graph. Okay, if I take q equal minus 2, in other words, I'm just minusing 2, it's going to take it as it is and shift it down. And you see the difference between q and a. A is not a vertical shift, it's a vertical stretch. Okay? It doesn't keep the same shape. When a vertical shift is the same, just shift it down. We alright with this, guys? Okay, now what we got to do, okay, you guys at home as well, you're going to finish up exercise 4. That's it, on page 132. Let's do it, guys. Bye-bye.